Hello everyone, welcome to chapter 3, supply and demand. In this PowerPoint, we'll be explaining the demand concept, the supply concept, the market equilibrium, it's where the demand and the supply meet, the consumer surplus and the producer surplus meet. This is as a first step. As a second step, we'll be studying the factors changing the demand, the factors changing the supply, and how the equilibrium change when the demand or the supply changes. The demand is whenever you want to buy certain quantities of a good at a certain price during a certain period. In fact, your demand depends on several factors. For example, if you want to demand ice cream, your choice depends on the price of ice cream, your preferences, whether you like ice cream or not, your income, whether you have enough money to buy ice cream or not, for example, temperature, whether it's hot outside or not, and many other factors. So, the demand function depends on several variables: the price, the income, the preferences, the temperature in case of ice cream, and many other factors. Ceteris paribus, check this concept in chapter 1. The quantity demanded is function of only the price of only one variable. So, ceteris paribus, now we study the demand using only the relationship between two variables, which are the quantity demanded and the price. All other variables are set as constant. So like we saw in managerial maths, an example for the demand function is QD equals, for example, 4 minus 0.1p. In the next slide, we will explain why we have this negative slope. We can calculate the inverse of this demand function, as you can see here in details. Now, the inverse demand shows the price function of the quantity demanded. The law of demand states that whenever the price increases, your willingness to buy decreases, so the quantity demanded decreases. Also, as the price decreases, the quantity demanded or your willingness to buy increases. So we have a negative relation between the price and the quantity demanded. This negative relation can be represented using a function, a table, or a graph. This is an example of a demand function. As you can see, the slope, the negative slope here, the minus 10, represents the negative relation between Q and P. If Q increases by 1 unit, P decreases by 10. Also, using a table, you can see that here we have the price, the quantity demanded for each price. Whenever the quantity demanded increases by 1 unit, the price decreases by 10. Whenever the quantity demanded increases by 1 unit, the price decreases by 10. Finally, we can show the demand on a graph. We plot each point the coordinates, quantity demanded with the price 0 with 40, 130, 220, 310, 40. As you can see, when we join the coordinates, the points, the line is decreasing, it's downward sloping. So the law of demand clearly states that whenever P increases, quantity demanded decreases. And whenever P decreases, quantity demanded increases. A negative relation between P and Q. This negative relation is shown along this demand line. Q increases, P decreases. Generally, the availability of substitutes, so the availability of similar goods serving the same purpose, can make a consumer switch whenever the price of a certain good increases to the substitute. The supply. The supply is whenever you want to sell quantities of a good at a certain price during a certain period of time. Now you are the seller. You think about more profits, so you're interested in higher prices. The quantity supplied also depends on several factors, like the price, the cost of production, technology, taxes, governmental restrictions. But using ceteris paribus concept, the supply function is also represented using only two variables, which are the quantity supplied and the price. For example, quantity supplied equals 0.1 P. We can also find the inverse supply function, which is the price function of Q, as we saw in managerial math. Remember, you're always interested in higher prices because now you are the seller. The law of supply states that whenever the price is higher, the seller is willing to sell more, so the quantity supplied increases. And as the price decreases, the seller is willing to sell less, so the quantity supplied decreases. Then we have a positive relation between the price and the quantity supplied. The law of supply can be represented using a function, a table, and a graph. An example for a supply function is P equals 0 plus 10Q. As you can see, the positive slope shows the positive relation between P and Q. If Q increases by 1 unit, the price increases by 10. Using a table, we have the prices and the quantity supplied for each price. You can also see that whenever the quantity supplied increases by 1 unit, the price increases by 10. Whenever the quantity supplied increases by 1 unit, the price increases by 10. Using a graph with the quantity on the x-axis and the price on the y-axis, we can plot the supply line using the coordinates from the table. As you can see, the more the quantity increases, the more the price increases. The supply line is upward sloping. Again, the law of supply states that we have a positive relation between P and Q. Why is that? Because the seller, if he sees higher prices on the market, he has more incentive to produce. The market equilibrium. The market equilibrium is where the demand and the supply meet. The demander and the supplier agree on a unified price and a unified quantity sold. This equilibrium can also be represented numerically using functions on a table and on a graph. Since it's a unified price for the demander and the supplier, we can find the equilibrium when setting P from the demand side equal to P from the supply side. Also, when setting the quantity from the demand side equal to the quantity from the supply side. Using a table, we can also see that P from the demand side equals P from the supply side, and Q from the demand side equals Q from the supply side. On a graph, when we plot the supply and the demand, we can see the equilibrium on the intersection point between the supply and demand. Let's explain more these ideas. This is a numerical example. We have the demand, we have the supply. Both are represented in functions. So to solve, let's set the price from the demand side equals the price from the supply side. P equals P. You can see in details the solving. First of all, we need to set all numbers with letters, with unknowns. Here the unknown is Q on one side. So we move minus Q to the right side of the equation, and the numbers without the unknowns on the other side. So we move the whatever number is here for example is 0, to the left side. Let's all remember that whenever we have this kind of equation, Q equals 40 over 20. Now we solve for the quantity at equilibrium, which is equals to. The equilibrium is not a quantity, it's a set of quantity and the price. Remember, a quantity and the price. So now we need to solve for the price. We replace the quantity at equilibrium in the demand side or in the supply, so in the demand function or in the supply function. We'll try replacing the quantity equals to in the demand. So we found out that the price equals 20. Also from the supply function, Q equals 2, we replace it, and we have the price. They are equal. So the equilibrium price and quantities are Q equals 2 and P equals 20. Now, using a graph, we can plot the equilibrium. First, on the x-axis, we have the quantities. On the y-axis, we have the price. We plot the supply and then the demand line. The intersection point is the equilibrium. The intersection point is the equilibrium. The intersection point points out to the price equals 20 and the quantity equals 2. For any reason, the price can be greater than the price at equilibrium. For example, P equals 30. Let's remember that our equilibrium price was 20 and our equilibrium quantity was 2. Okay, so P equals 30 is obviously not our equilibrium. At price equals 30, or any price higher than equilibrium, we have a market surplus. We'll explain what market surplus is. First, let's calculate the quantity demanded at price equals 30. This is the demand function. We replace 30 with P with its value, which is 30, and we solve for Q demanded. Remember, while solving, we put all our variables one side, all the numbers on the other side, and we solve. QD equals 1 in this case. Now let's calculate the quantity supplied at P equals 30. Again, this is our supply function. We replace P with its value, which is 30, and we solve. Follow step by step these solving, and we always repeat the same steps. Here, QS equals 30. Now let's compare the two. In fact, QS is greater than QD. Whenever QS is greater than QD, we have a market surplus. The quantity supplied is higher than the quantity demanded. This surplus is the difference between the two. QS minus QD, 3 minus 1 equals 2. In fact, the quantity supplied is 3. We have a surplus on the market of 2. So practically, we only traded a quantity equals 1, which is the lowest quantity between the two. QD equals 1. The lowest quantity between QD and QS. Okay, graphically. Again, we have the graph, the supply line, the demand line. As you see, here's the equilibrium, P equals 20, Q equals 2. Now, let's set our new price, P equals 30. Here it is. Okay, at P equals 30, the intersection with the demand line and the intersection with the supply line gives us a quantity demanded of 1 and a quantity supplied of 3. The gap between QD and QS is the surplus. The surplus is 2. The market surplus does not stay for long on the market. So, in fact, producer would want to get rid of their surplus. So they decrease their prices. They do discounts, for example. Therefore, QS will decrease as the law of supply states. QD will increase as the law of demand states until equilibrium is reached. For any reason, the price on the market could be lower than the equilibrium price. For example, P equals 10. Remember, the equilibrium price is 20. So obviously, P equals 10 is not the market equilibrium. In this case, we have a shortage on the market. Let's explain this. First, let's calculate the quantity demanded at P equals 10. We'll repeat the steps from the previous slide. Here's the demand function. Let's replace 10 in its value and solve for Q demanded. Q demanded equals 3. Now let's calculate the quantity supplied at P equals 10. Again, here's the supply function. Replace P with 10 and solve for Q. Qs equals 1. We'll compare the two values. We'll see that Q supplied is less than the Q demanded, so we have a shortage on the market. This shortage equals the difference between the two values, which is 2. The quantity demanded is 3. We have only QS available, which is 1, a shortage of 2. Then practically, we only sold one quantity. The quantity traded is only QS equals 1, which is the lowest value between the two, between QS and QD. Graphically, here's the equilibrium, supply function, demand function, and here's the equilibrium. Let's assume our lower than the equilibrium price 10. The intersection with the supply curve gives us a quantity supplied equals 1. The intersection with the demand curve gives us a quantity demanded equals 3. The gap between the two is the shortage equals 2. The market does not stay at shortage. In fact, when you have a shortage on the market, producer will tend to increase their prices. As the law of supply states, when P increases, QS will increase. As the law of demand states, when P increases, QD will decrease until equilibrium is reached. Now let's analyze equilibrium, surplus, and shortage using a table. Here's a table. We have the prices. For each price, the quantity supplied. For each price, the quantity demanded. Okay. At P equals 40, which is a price higher than equilibrium, we can notice that QS is higher than QD. We have a surplus on the market. We can view this surplus, 1, from the price, which is higher than the equilibrium, which is 20. 2, when the QS is greater than QD. The surplus equals the difference between the two. Surplus equals 4. The quantity traded is the lowest between the two, so equals QD. Alright. At P equals 20, QS equals QD, so this is the equilibrium. No surplus, no shortage. At price equals 10, this price is lower than the equilibrium. QS is lower than QD. We have a shortage. The shortage equals the difference between the two. 3 minus 1 equals 2. The quantity traded is the lowest between the two. So QS equals 1. We have a shortage. You can try the equilibrium problems, the surplus problems, and shortage problems with worksheet 2, problems 1, 2, and 4. Consumer surplus and producer surplus. Let's start with the consumer surplus. The consumer surplus is the difference between the price a consumer was willing to pay and what they actually paid. Imagine you wanted to go and buy a phone. You had in mind to pay maximum $300. You went to the store and you found one, the one you had in mind, um, priced at $250. The difference between the $300 you were willing to pay and the $250 you actually paid is $50. This is what we call a consumer surplus. On a graph, you can see the maximum price you are willing to pay, which is 40, and the price you actually paid, which is the equilibrium price, 20. The difference between these two times the quantities is the consumer surplus. In fact, you can shade the consumer surplus with the area under the demand curve, under the demand line, limited with the price. This is the price, 20, and the quantity, 2. So the area under the demand and limited, it stops at the price 20. The consumer surplus is represented with this triangle. Okay, the producer surplus. It's the difference between the minimum price a producer is willing to receive and the price they actually received. Imagine you own a phone store, you had a cell phone you'd like to sell, you had in mind that you were willing to sell this phone at a price of $200. A consumer came in, so a client came in and wanted this phone and offered you $250. Obviously, you will sell at this price. You were willing to sell this phone at 200 and only receive 200, but a client came in and he offered $250 for this phone. The difference between the 200 and the 250 is the producer surplus. Here you can see the price you actually received is the equilibrium price at 20. The price you were willing to receive, which is 0, here theoretically, for the example, we took it as 0. The difference between the two is the consumer surplus times the quantity. Actually, you can shade the producer surplus as the area above the supply line and limited with the quantity and the price. This is the quantity and this is the price. So as you see, the producer surplus is this surface, this area, this triangle. The consumers and the producers form our economy, our society. So the social surplus, the economic surplus, the total surplus is consumer surplus plus the producer surplus. So it's the whole triangle. The consumer surplus and the producer surplus at a market surplus. whenever the price is not at equilibrium. For example, if the price is higher than the price at equilibrium, so we have a market surplus. So for example, the price equals 30. This is the price and this is the demand. Now, the price you actually paid if you're a consumer and the price you actually received if you were a supplier is 30. The consumer surplus is this area now, and as you see, it decreased because of the increase of price. The producer surplus is this area. It decreased because of the price. The social surplus also decreased because CS decreased. As you see, here we have a lost area compared to the other graph, to the previous graph. This is what we call a dead weight. This dead weight represents the loss for the society in social surplus, since social surplus decreased. So whenever we have a surplus, a price that is higher than the equilibrium price, consumer surplus decreases, producer surplus increases, and social surplus will decrease. Now we have a dead weight. You can try this out, the producer and consumer surplus problems in worksheet 2, problem 6 and 7. In this part, we're going to explain the factors that will change the demand, the supply, and the equilibrium. Okay, here's a graph with Q on the x-axis and P on the y-axis. This is the demand line. It's downward sloping. Okay, when we say a change in demand, we mean an increase or a decrease. When we say that the demand increases, it means that the demand moves to the right. You need to pay attention. I'm saying the demand moves to the right, not the quantity demanded. The quantity demanded increases whenever the price decreases. We're not talking about this. We're not talking about the law of demand. No, we're talking about the change of demand. So the change of the line, the whole line. Okay, when we say that the demand increases or moves to the right, it means that the demand moves as a whole to the right, as you can see in front of you. What does it mean exactly? It means that for the same price, the quantity increases. Okay, the demand can also decrease. Again, it's the demand that is decreasing. When the demand decreases, the demand moves to the left, as you can see in front of you. What does it mean? It means that for the same price, the quantity, this is the old quantity, the black one, and this is the new one. The quantity demanded decreases. For the same price, QD decreases. Why? What changes the demand? A few factors changes the demand. For example, the income. The demand increases or moves to the right, as we saw in graph 1, whenever the income increases, if the good was a normal good. These are examples. If income increases, the demand moves to the left, as we saw in graph 2. whenever the good is inferior. Every case, its inverse is also correct. So, if the good is normal, the income decreases, the demand decreases. Graph 2. If the good is inferior, if income decreases, demand increases. These are examples. For necessities, if income increases or decreases, the demand remains the same. It does not change. These are examples. The price of related goods will change the demand. If good X increases, the price of good X increases, the demand of good Y increases, like we saw in graph 1, whenever the goods X and Y are substitutes. The inverse is also correct. These are examples. If the price of good X increases, the demand of good Y decreases, like we saw in graph 2, whenever the two goods X and Y are complementary goods. The inverse is also correct. These are examples. Whenever you like more a good, your demand for this good increases. The inverse is correct. Whenever the number of buyers increases, the demand increases. Whenever the number of buyers decreases, the demand decreases. If prices expected for tomorrow to increase, today the demand will increase. How does the supply change? The supply as the demand can increase or decrease, so move to the right or move to the left. If the supply increases, so it moves to the right. What does it mean? It means that for the same price, the quantity increases. The supply can also decrease. It moves to the left. It means that for the same price, the quantity decreases. What changes the supply? Prices of resources. The price of a resource is a cost. Whenever the cost increases, the supply decreases. And whenever the cost decreases, the supply increases. Change in technology. Whenever we have an advancement in technology, the supply increases. Whenever we have a setback in technology, the supply decreases. The more sellers we have, the more the supply. The less sellers we have, the less the supply. Prices of other goods the producer can produce. For example, a producer can produce chairs and tables. If prices of tables increase, he has more incentive to produce tables and sell tables than sell chairs. So the supply for chairs will decrease and the supply for tables will increase. The inverse is also correct. Price expectations. If the expected prices are higher tomorrow than today, so the supply today will decrease. The inverse is correct. Taxes. Taxes are also costs on production. If taxes increase, supply decreases, and the inverse is also correct. Government restrictions on imports. If the government sets restrictions on imports, so it has taxes on imports, the domestic supply, the supply inside a country, will increase. They have more incentives to produce. The inverse is also correct. Following the supply or the demand change, the equilibrium also changes. Here we have an increase in demand, so the demand moves to the right. The black was the old demand, the red is the new demand. As you see, the demand increases and moves to the right. The old equilibrium is the intersection between the black and the purple. The new equilibrium is the intersection between the red and the purple. What happens to equilibrium here? When we say what happens to equilibrium, we mean what happens to the price at equilibrium and the quantity at equilibrium. All right. As we see here, the quantity at equilibrium increases, the price at equilibrium also increases. So the change in equilibrium is that the price and the quantity have increased. Okay. Now, the demand decreases, the demand moves to the left. The red is the old demand, the black is the new demand. As you see, the demand moves to the left. The equilibrium between red and purple is the first equilibrium. The intersection between the black and the purple is the new equilibrium. You can see that the equilibrium, the quantity at equilibrium decreases, and the quantity at the price at equilibrium also decreases. Note that both cases, the supply did not change. Okay, what happens if the supply increases? The old supply is the black one, the new supply is the red one. This is the old equilibrium, this is the right equilibrium. As you can see, the quantity at equilibrium increased and the price at equilibrium decreased. The demand did not change. In this case, the supply decreases, it moves to the left. The old equilibrium, the new equilibrium. As you can see, the quantity at equilibrium decreased, the price at equilibrium increased. Also note that the demand here and in the previous slide did not change. Either the demand changes or the supply changes. So whenever you are facing a problem, think about a question while responding to two questions. One, is it the supply or the demand? Two, is it a good thing? So moves to the right. Is it a bad thing? Moves to the left. As a general rule. Okay, you can try this out yourself with worksheet 2, problems 3, 5, and 8. This is the end of the chapter. Thank you for following.